is the solution of CSIR Net December 2018 question paper. This is for booklet C and for quantum mechanics. These are all quantum mechanics questions appeared in this question. So the first question is 26th question for this is a quantum mechanics question. The ground state energy of an anisotropic harmonic oscillator described by the potential Vxyz is equal to half m omega square x square plus 2m omega square y square plus 8m omega square z square. So we have to calculate the energy eigenvalue. The potential is given, so we can write this potential like this: Vx comma y comma z is equal to half m omega square x square plus half m, this we can write as 2 omega ka whole square into y square plus half m 4 omega ka square into z square. So we know that for a this is a three-dimensional harmonic oscillator. We know that the potential is given by Vxyz. Vxyz is equal to half m omega x square into x square plus half m omega y square into y square plus half m omega z square into z square. So from this we know that omega x is equal to omega y is equal to 2 omega and omega z is equal to 4 omega. And we also know that the energy eigenvalue of a three-dimensional harmonic oscillator is E nx ny nz is equal to nx plus half h cross omega x plus ny plus half h cross omega y plus nz plus half h cross omega z. So we have to calculate the ground state energy. So for ground state energy, nx is equal to ny is equal to nz is equal to 0. So the ground state energy is given by half h cross omega x plus half h cross omega y plus half h cross omega z. So this would be equal to half h cross omega x is omega y is 2 omega and omega z is 4 omega. So this would come out to be 7 by 2 h cross omega. So the correct option is second, 7 by 2. Now the next question is the product delta x into delta p of uncertainty in the position and momentum of a simple harmonic oscillator of mass m, angular frequency omega, in the ground state ket 0 is h cross 2. So we have been given that the product of uncertainty in the ground state, so the product of uncertainty in the ground state, this is equal to h cross by 2. We also know that the formula for the uncertainty product delta x into delta px is n plus half h cross. It's clear for the ground state n equal to 1, so delta x into delta px is h cross by 2. Now the value of the product delta x into delta p in the state. Now we have to calculate the value of this product in this state. So let this state be ket psi given by e raised to power minus I p cap L by h cross ket 0. So we have to calculate in this state. Now we can calculate its bra. That will be 0 e raised to power I p cap L by h cross. So Now we can calculate the product in this state. We have to calculate the product delta x into delta p in this state. So we know that the uncertainty, how we calculate the uncertainty? Uncertainty delta x is under root x square की expectation value minus x की expectation value का square. These are operators x square and x cap. And how we calculate this expectation value? X square की expectation value we calculate like this. If we want to calculate in the ground state get 0, we calculate like this: bra 0 x square cap get 0. Now to calculate this in the cat psi state, if you want to calculate in this state, you can calculate like this: square की expectation value, so cat psi square cat psi. So you can put the value of bra psi and cat psi over here. So e raised to power I p cap L by h cross, and x cap square e raised to power minus I p cap L by h cross bra get 0. So this exponential term will cancel and this would come out to be bra 0 x cap square cat 0. So this is same as calculating in the ground state cat 0 state. So similarly for others, if you want to calculate the expectation value of x cap, so if we calculate in cat 0 state, or if we calculate in that cat psi state, that would come out to be similar to above methods. So similarly for the uncertainty of momentum, which is p square की expectation value minus p की expectation value का square, so it would come out to be same in both the state. Thus that is why the uncertainty product delta x into delta p would come out to be same as it is in the ground state, that is h cross by 2. So the correct option is third, h cross by 2. Now coming to the next question. So this is 28th question. Let the wave function of the electron in the hydrogen atom be psi r. So this is given wave function of the electron in the hydrogen atom, where phi n l m are the eigenstates of the Hamiltonian in the standard notation. The expectation value of the energy in this state, so we have to calculate the expectation value of the energy. Now we have been given these are the probability amplitudes: 1 by root 6, 2 by under root 2 by 3 and minus 1 by root 6. Square of these gives the probability of the corresponding eigenstates. Okay, so if we do the square of all square and add these probability amplitudes, it would come out to be 1. So this is coming out to be 1. This is okay. So we know that the expectation value of energy is given by sigma n pn en. So we have three terms here: p1 e1 plus p2 e2 plus p3 e3. Now p1 is square of this probability amplitude, so 1 by 6 e1 plus 2 by 3 e2 plus 1 by 6 e3. Now Energy of an electron in a hydrogen atom is given by En is equal to minus 13.6 by n square electron volt. So for the first term, n is equal to 2, because in phi lm the first represent the principal quantum number n. So in the first term, n is equal to 2. So 1 by 6 E1 will be minus 13.6 by 2 ka square electron volt plus 2 by 3. The second term, for second term also n is equal to 2, so minus 13.6 by 2 ka square electron volt plus, for the third term n is equal to 1, so minus 13.6 by 1 ka square electron volt. So this would come out to be 1 by 6 minus 3.4 electron volt plus 2 by 3 minus 3.4 electron volt plus 1 by 6 minus 13.6 electron volt. So we calculate this all, it would come out to be minus 5.1 electron volt. So the correct option is fourth, minus 5.1 electron volt. Let's come to the next question. 3 incident spin half particles of mass m are confined to a one-dimensional box of length L but are otherwise free. Assuming that they are non-interacting, the energy of the lowest two energy eigenstate in terms of pi square h cross k square by 2 ml square are. So we have 3 spin half particles, so they are fermions. So they are fermions, 3 spin half particles. They are fermions, they will follow the Pauli exclusion principle. Pauli exclusion principle. So we know that the energy eigenvalue of a particle in a one-dimensional box of length L is given by En is equal to n square pi square h cross k square by 2 ml square, where n is equal to 1, 2, 3, dash. N is a principal quantum number. Now, assuming that they are non-interacting, the energy of the lowest two energy eigenstates. So for the ground state, if the system is in the ground state, we have two levels, n equal to 1, n equal to 2. If we follow the Pauli exclusion principle, the first two particles would be in the ground state for n equal would be in n equal to 1, and the other particle would be n equal to 2. And for the excited state, first excited state, one particle would be in the n equal to 1 state, and the other particle would go into the n equal to 2 state, n equal to 2 level. So for the ground state, the total energy would be 2E1 plus E2. So that would come out to be 2 for n equal to 1 would be pi square h cross k square by 2 ml square plus E2, that would be 4 pi square h cross k square by 2 ml square. So this would be 6 pi square h cross k square by 2 ml square. And for the first excited states, the energy would be, total energy would be E dash E1 plus 2 E2. So that would be pi square h cross k square by 2 ml square plus 8 pi square h cross k square by 2 ml square. That would be 9 pi square h cross k square by 2 ml square. So the correct option is, in terms of pi square h cross k square by 2 ml square, 6 and 9. So the correct option is second, 6 and 9. So these are all 5 marks question. So let's come to the 75th question. Consider the operator Ax is equal to Lypz minus Lzpy, where Li and Pi respectively denote the component of the angular momentum and the momentum operators. The commutator Ax, x, where x is the x component of the position operator, is, now this is a commutation relation question, so we can use we have used these formulas, these all formulas in our solution. We will use these formulas. So this is a commutation question. So commutator of Ax comma x would be equal to, we know that Ax is given Lypz minus Lzpy comma x. So we can use this relation and we can write it as commutator of Lypz comma x minus Lzpy comma x. Okay, commutator of a comma b plus minus c is equal to commutator of a comma b plus commutator of a comma c. Now we can use this relation commutator of ab comma c. So we will use this relation and we can write this as commutator of Ly comma x into pz plus Ly commutator of px pz comma x and minus Lz comma x into Py minus Lz Py comma x. So in these four terms, these two terms would come out to be 0 because commutator of pz comma x is 0 and commutator of py comma x is 0. Commutator of x comma px, y comma py and z comma z is ih cross. All other combination of x and momentum and position are 0. So these two are 0. And commutator of Ly comma x, we can use these 6 relations. Commutator of Ly comma x, Ly comma x is minus ih cross z into pz, and commutator of Lz comma x is ih cross y py. So this would come out to be minus ih cross z pz plus y py. So the correct option is first, minus ih cross z pz. Correct option is first. Now let's come to the next question. A system of spin half particles is prepared to be in the eigenstate of sigma z with eigenvalue +1. So we know that for the eigenstate sigma z, for the eigenstate sigma z, it is 1 0 for the eigenvalue +1, and for eigenvalue -1 it is 0 1. Okay, now the system is rotated. So initially the system is in the state for the eigenvalue +1. So system initial state, this is the initial state, this is in the state 1 0. Now the system is rotated by an angle of 60 degree. So rotated by 60 degree about x-axis. After rotation, the fraction of the particles that would be measured to be in the eigenstate sigma z with the eigenvalue +1. So we know that the rotation matrix about the x-axis is given by cos theta by 2, I sin theta by 2, minus I sin theta by 2 and cos theta by 2. So if we put theta is equal to 0, so Rx theta is equal to, we put theta is equal to 60 degree. This would come out to be root 3 by 2 I by 2 minus I by 2 and root 3 by 2. Now for the final state, final state is in the eigenstate sigma z with eigenvalue plus 1. So for the final state, get psi theta would be Rx theta. Rx theta is equal to 60 degree into 1 0 for the sigma z plus 1 eigenvalue. Okay, so this would be root 3 by 2 I by 2 minus I by 2 and root 3 by 2 into 1 0. So this would be equal to root 3 by 2 and minus I by 2. Now this we can write it as, this term we can write as root 3 by 2 into 1 0 minus I by 2 0 1. Now from this expression we see that, we see that if sigma z is measured on ket psi theta, for eigenvalue plus 1, the probability will be square of this, that is the probability will be 3 by 4 for the eigenvalue plus 1, and the probability would be square of this, that is 1 by 4 for the eigenvalue minus 1. So you have to calculate the eigens with the eigenvalue plus 1, so the answer is 3 by 4. It is the fourth option is correct. So let's come to the next question. A one-dimensional system is described by the Hamiltonian H, which is equal to p square by 2m plus lambda mod x, where lambda is greater than 0. Now we have to calculate the ground state energy, varies as a function of lambda. So here we can use, so in this question we can use the WKB method. So we will draw the potential. This is the potential term. Vx is equal to lambda mod x. So let's draw the potential term. This would be x. This is Vx, and this is like this. So this is a symmetric potential, boundary at E by lambda plus E by lambda. This is 0. So by using the WKB method, so this is a symmetric potential with two rigid walls at minus E by lambda and plus E by lambda. So the quantization rule, for potential wells with two rigid walls, we know that it is given by integral x1 से x2 px dx is equal to n pi h cross. So x1 is minus E by lambda, x2 is E by lambda, and px dx is equal to n pi h cross. So we know that px is equal to under root 2m e minus v. So this is equal to under root 2m e minus lambda mod x. So this term come out to be twice of integral 0 से e by lambda under root 2m e minus lambda mod x dx is equal to n pi h cross. Now We can take E common, so under root 2me, taking E common, 1 minus lambda mod x by E into dx n pi h cross. So this would come out to be twice of integral, or we can take 2me outside the bracket, outside the integral. So under 2 under root 2me 0 से e by lambda 1 minus lambda x by e raised to power half into dx is equal to n pi h cross. So this would simply be, now here we can put a substitution. Let's take lambda x by e is equal to t. So lambda dx by e is equal to dt, and dx would be equal to dt e by lambda. So using this, so when x is equal to 0, t will be 0, and when x equal to e by lambda, t would be 1. So 1 minus t raised to power half into e by lambda dt is equal to n pi h cross. Now we can take e by lambda outside the bracket. So 2 under root 2m. So e raised to power half into e would be e raised to power 3 by 2 by lambda integral 0 से 1 minus t raised to power half is equal to n pi h cross. So this is the constant term. This is constant. So it's clear that e raised to power 3 by 2 by lambda is directly proportional to n. So e raised to power 3 by 2 is directly proportional to n lambda. So e raised to power, so e raising both sides by 2 by 3, so e would be proportional to n raised to power 2 by 3 and lambda raised to power 2 by 3. Hence e is proportional to lambda raised to power 2 by 3. Hence the correct option is second, lambda raised to power 2 by 3. So let's go to the next question. 47th question is, if the position of the electron in the ground state of hydrogen atom is measured, the probability that it will be found at the distance r greater than equal to a naught. A naught is the Bohr radius is nearest to. So for the ground state, the radial wave function is given by r10, n equal to 1 and l equal to 0. r10 is given by, this is the ground state, 2 by a naught raised to power 3 by 2 into e raised to power minus r by a naught. A naught is the Bohr radius. Now we have to calculate the probability. To calculate the probability of r greater than equal to a naught. So this probability will be integral a naught से infinity r10 के mod का square into r square dr. So probability is equal to 4 by a naught cube integral a naught से infinity r square e raised to power minus 2 r by a naught into dr. Now we take the substitution here, 2r by a naught, let 2r by a naught is equal to t. So 2 dr by a naught is equal to dt, dr would be equal to dt a naught by 2. Putting it here, so 4 by a naught ki cube integral. So when r goes to a naught, t goes to 2, and when r goes to infinity, t goes to infinity. So from 2 से infinity, r, the value of r is t a naught by 2. So t a naught by 2. square into e raised to power minus t. dr is dt a naught by 2. We can take a naught by 2 outside the integral, so this would come out to be, this would be 4, and that would come out to be half integral to infinity t square e raised to power minus t dt. Again, we have to just solve this integral, so this would come out to be half. We can write this integral as in two parts, 0 से infinity t square e raised to power minus t dt minus integral 0 से 2 t square e raised to power minus t dt, and this is the gamma function. You can use the property of gamma function in this integral, so this would be gamma 3 integral 0 to infinity x raised to power n minus 1 e raised to power minus x dx is gamma n. So this is 3 minus 1, so gamma 3 minus, now we can solve this integral. Take this as the first function, this is the second function. So first function into integral of second function minus integral of differentiation of first function into integration of second function. So this would be positive dt, and gamma 3 is 2 factorial, which is 2 minus t square e raised to power minus t plus, we can again take this as first function, this as second function, so twice of first function into integration of second function minus integral of differentiation of first function into integration of second function. Differentiation of t is 1 e raised to power minus t. This would be positive. So this would be like this. Now 2 minus t square e raised to power minus t plus 2 minus t e raised to power minus t plus its integration is e raised to power minus t only, so minus e raised to power minus t. Now we can open the bracket, half 2 minus, this will be minus t raised to power minus t plus minus 2 t raised to power minus t minus e raised to power minus t. Now we can substitute the limit, it's from 0 to 2. The limits were 0 to 2 as here. That will be 4 minus 4 e raised to power minus 2 that will be 2 to power minus 2 plus, when we put 0, this and this term would be 0 and this would give e raised to power 0. So half, this is 2, this is 2, this would cancel and all term would become positive, and 4 plus this would be 10 e raised to power minus 2. So this will be 5 e raised to power minus 2. 5 by e square is 0.676. So out of these options, the second would be the closest. Second option is correct. So these were all the quantum mechanics question. 5 questions were of 4 marks, so total 20 marks, and 4 questions of 3.5 marks, so 14 marks. So total quantum mechanics came of 34 marks.